Hello, my name is Sam. I am an online maths tutor, and this is the 5th episode in a series of episodes about GCSE maths, quadratics. This episode is on quadratic inequalities and solving them. We've already done solving quadratics by factorising, completing the square, and the quadratic formula. So let's get straight into the video. So what am I talking about with quadratic inequalities? Well, there is an equation written at the top of the screen: x squared minus x minus 20 is less than 0. And I've drawn the graph there of y equals x squared minus x minus 20. So this is just a simple graph of this expression. And well, what is this expression actually talking about? Well, it's saying where is this less than 0? So this expression, x squared minus x minus 20, so for what values of x would this left side be less than 0? And so graphically, this means on this graph, where is this less than 0? Well, it's this area down here. So it's all of this area down here, which is less than 0. That is what we are looking for. So let's work out how to find that and how to solve that. So this is going to incorporate lots of solving quadratics. I'm going to do this mainly by factorising. You could get other questions to do with using the quadratic formula or completing the square. So just be aware about that. If you're confused about any of the factorising I do in this episode, have a look at my factorising quadratics episode or one of the others on YouTube. There's plenty out there. So let's start. So we have x squared minus x minus 20 is less than 0. So firstly, I'm going to want to try and find the roots of this equation. So I'm going to change this to be an equal sign just so I can find the roots. We will replace this in a minute. So now this is a normal quadratic, x squared minus x minus 20. We're looking for two numbers that add to make minus 1 and multiply to make minus 20. You can have to think about that for a minute. There's going to be minus 5 and positive 4. So if x minus 5 and x plus 4 is equal to 0, we can then solve this where x minus 5 is equal to 0, so x is equal to 5, x minus 4 is equal to 0, so x is equal to minus 4, so x plus 4 is equal to 0. So x is equal to minus 4. We can then see on this graph here that this is in fact minus 4, and this is positive 5. So those are the roots of our equation. So what is the actual answer? Well, this is an inequality. We're looking for where this is less than 0. So we know our root is 5, we know we have a root at minus 4, and these are where the graph is equal to 0, and we want where it is less than 0, and we know that this graph is less than 0 in between these points. And so what values of x does that be? Well, it's any value of x that comes between minus 4 and 5. This basically says that if you pick any value of x, so we use 1, if we plot 1 on here, it's going to be around about here. The value on the graph is down here, and that is less than 0. So we have solved this equation. Let's go on to the next example. X squared is less than or equal to 100, and we want to solve this. So firstly, we want to put it in a format which is more useful for us. Of course, you could solve for x squared and find out where that is less than 100, but that is going to be quite difficult. Instead, we're going to simply say that this is x squared minus 100 is less than or equal to 0. So we're saying the graph of y equals x squared minus 100. If you were to draw this graph, where is that less than or equal to? So it has to be below or on the x-axis. So we're going to start this much like we have with the other questions, and we're going to solve this quadratic. So this is a special quadratic. It is a difference of two squares. This is covered in one of my earlier videos. Basically where the first term is a square number and the second term is a square number. And so this is a difference of two squares, and it can be factorised into x plus 10 times by x minus 10, and that's going to be equal to 0. This is because if you are to expand this, you're going to get x squared minus 10x plus 10x minus 100. These central terms here are going to cancel, and you're going to be left with x squared minus 100. So we can take this factorisation, we know that it is equal to 0, and we can say, okay, for both of these brackets, we can say that x plus 10 must be, well, for both of these brackets, one of them is going to be equal to 0, so x plus 10 is equal to 0, that gives us x is minus 10, and when x minus 10 is equal to 0, we get x is equal to positive 10. And so our root of this equation, y equals x squared minus 100, is going to be minus 10 and 10. However, we want to solve this expression for less than or equal to 0. So again, as we looked at in the previous example, we can have a look at a graphical version of this. And this is going to be a very crude version of this graph, but it is much similar to what the actual graph will look like. So this root is going to be minus 10 and this root is going to be positive 10. Now I would really recommend drawing a graph in the exam. It really helps to visualize things and it can help you to just understand what's going on. As sometimes, especially when you get negatives in front of these x squareds and you start getting middle terms, this can get quite complicated, and just to make sure you get it right, you want to always draw the graph, or even just a sketch. You don't need to draw it, you just need to sketch it, just so you can properly see what you're actually looking for. So we're looking for where this is less than or equal to 0. Of course, that is going to be this area here under the x-axis, since this is where this line, or this graph, x squared minus 100, is less than or equal to 0. And is for any x value between minus 10 and positive 10. So we can say that between minus 10 and positive 10, we are going to have our answers. However, this is a less than or equal to sign, and so we must change this to be a less than or equal to sign in the answer, as our x value can be less than or equal to 0. And since at minus 10 and 10, this equation is equal to 0, we must include these in our answer. That is very, very important. You will lose a mark if you do not draw the extra equal to sign on your comparison sign. So let's go to our final example. This one is slightly harder. This is 6x plus 27 is greater than x squared. So graphically, we're saying where is the line 6x plus 27 greater than x squared? Let's draw this down. So 6x plus 27 is quite a steep graph, something like that. And we're saying where is that greater than x squared? Well, x squared looks something like that. We're looking for this area up here where this, oops, sorry, that is not correct. We are looking for this area down here in between the two graphs, as that is where this line is above the x squared line. However, we are not going to solve it like this, as that is extremely complicated and would really not be very fun. Instead, we can make this all into one equation. So if we are to write down 6x plus 27 is greater than x squared, we can swap these things around. So I'm going to put the x squared on the left side and the 6x plus 27 on the right, just to make this easier to understand. We must then flip this sign as well. 6x plus 27. I'm then going to subtract 6x from both sides, and I can subtract 27 as well, and that is all going to be less than 0. Now this is looking much more familiar than one of our previous examples. Sorry, this is looking as familiar as one of our previous examples in comparison to what we started with. And so we can go ahead and solve this. So just like any other quadratic, we're going to look for two numbers which are going to add to get minus 6 and multiply to get minus 27. Again, I'm solving this by factorising, just as it seems to be the quickest method with this quadratic which I'm given. You could complete the square, you could use the formula, although I would not recommend using the formula here, as it is going to be too long and too much effort, and it's going to take too long, and in the exam you do not want to be taking too long for this kind of stuff. So two numbers that add to get minus 6 and multiply to get minus 27. Well, I know that 9 times 3 is 27, and the difference between 9 and 3 is 6. So if I have a minus 9 and a positive 3, that they add to get minus 6 and multiply to get minus 27. So I'm going to have an x minus a 9 and an x plus a 3, and that is going to be less than 0. Again, I'm going to want to change this now to be an equal sign so I can find my roots. So x minus 9 times by x plus 3 is equal to 0. Where x minus 9 is equal to 0, we have x equals 9. And where x plus 3 is equal to 0, we have x equals minus 3. And these are our two roots. We have 9 and we have minus 3. So let's just quickly draw our quadratic. Again, this is just a sketch. I'm not doing any plotting points. I'm not taking ages to do this. I'm simply just jotting down the important information in the graph. So 9 and minus 3, this is a pretty standard quadratic. It's just 1x squared and it's positive. This should probably be a bit steeper. I've drawn it more like a bowl here, but it's okay for a sketch. So this is going to be x equals 9, and this here is going to be x equals minus 3. I'm looking for where this is less than 0. So it looks like we're looking for where this is greater than something, but since we've swapped the x squared around and we've done some stuff to this equation, it is going to be less than 0. Again, we're looking for where this line is less than 0, and it is in fact this location in the middle. So between minus 3 and 9 are the x values that we are looking for. So our answer would be minus 3 is less than x is less than 9. Again, there is no inclusion sign in here, there is no equal to, so these are fine as they are. And it is important to note that if this question was changed the other way around, so if I was given the question 6x plus 27 is less than x squared, my final inequality would be x squared minus 6x minus 27 is greater than 0. Sorry, that says 77, not 27. And so this factorizes in much the same way. We're going to get x equals 9 and x equals minus 3. But what is the answer going to be this time? Well, we're going to have a different graph. We're going to have the same graph in terms of the line that we have, but we're going to be looking for something much different. So again, this is 9 and this is minus 3. And we're looking for where this graph is greater than 0. And as we can see, as this line goes up here, this part of the line is above the x-axis. And so this is good. We want all of this. We want everything off to infinity in this positive x direction. And then while we look at the second side, and this line also goes up, it kind of comes back on itself, but that's just a drawing. So we want everything on this side as well. And well, that is where x is less than minus 3. So our answer in this instance changes to be 2 inequalities. Here we're looking for any value of x which is greater than 9, or we are looking for any value of x which is less than minus 3. And these would be your answers. This does not simplify into one inequality, as they both satisfy the original expression for where this is greater than 0, as any value above 9 or less than minus 3 would satisfy this. Okay, thank you for watching. I hope that's helped your understanding, and see you soon.